Hey, hi everybody. It's about time I posted a bit of an update. So over the last little while in the game development, I've decided it was time for like a deeper dive into understanding refresh rates. So monitor refresh rates, frame rates, and how they impact programming the game. I've spent quite a few days and hours sorting through everything just so that I could get a move on and get my game moving and keep progressing with learning. So it's what I've discovered is that there is a lot to learn, and it's a very broad topic with a lot of related concepts. So I came across different things like delta time, delta motion, capping frame rate, time steps, physics, all this stuff. And it's very, very easy to get lost in all of the material. So I thought I would update everybody, and my hope is that giving you kind of a bird's eye view of everything that I've been able to digest so far will save you some time so you don't have to spend as much time as I did. And the goal here is that, yes, if you're a beginner like me, that you just want to keep moving. You want to implement something simple to get you to the next step. Because a lot of the time when you're trying to learn more complicated things, you need to wait a little bit till you have more experience before you can get the most out of those complicated approaches anyway. So it's kind of a wasted effort to try and, you know, get it all done at the beginning, right? So yes, it's very hard to know where to start, but I had a few goals when I got started with this. I really wanted to understand how to make my entities move smoothly, and I wanted fine control over their speed. So I ran into situations where my characters were moving too quickly. I couldn't get them to slow down enough, and other things like that. And then I came across problems like how to reliably detect collisions and how to adjust my game, how to make my game play well on different refresh rates, monitor refresh rates. And these are the sort of things that were in my mind when I started to dive into this. So what I did find out, I got as far as solving most of the problems. I'm still not quite sure how to make everything behave the same way on different monitor refresh rates, but I know that's coming up. So when I figure that out, I'll be sure to post an update again on that. So if you'd like to keep watching, then I'll share the few things that I discovered. First, what is the problem exactly? The problem is that when you have different refresh rates on your monitor, when your frame time in your game loop runs too quickly, they're not in sync, and that causes jankiness with your program, and it makes it hard to get smooth movement with your entity characters. So the way that you can handle this, as you can imagine, there are simple ways and there are complicated ways. The more complicated ways that I found online, and one article that keeps coming up time and again, is called Fix Your Time Step. And of course, I'll link to that down below. And that advocates for an approach where you have a fixed time step, so a predictable amount of time, a set amount of time for updating your physics, and then you allow in other parts of your game loop to render as quickly as possible. So you separate the two. You separate physics updates with rendering from rendering, and the physics updates will be a reliable interval, whereas rendering can happen as quickly or as slowly as need be for the monitor that you have. So the idea is, the promise is that you get the best of both worlds. You get reliable physics with smooth rendering that matches whatever monitor is playing the game. The problem, though, is that makes an assumption that the updates should complete in full before rendering is done. And that makes sense. Like, that's usually the way I would think about it too, at least as a beginner, right? But I've read other opinions, or come across other opinions from Casey Muratori in the Handmade Hero series, where he makes a point of saying that actually you get a lot of benefit from keeping the updates and the rendering closer together. So as an example, if you have an array of entities and you're separating the two operations, you would have to iterate through that full array of entities, update their position, and then in another step later on in your code, iterate through that same array again to render the entities. And so that's a lot of wasted work. And further, it doesn't take advantage of modern CPU architecture, which has, cache lines and all that, so that it will work as efficiently as possible. So by separating those, you lose all of that. But that's not talked about in the Fix Your Time Step article. Instead, it assumes that the biggest benefit comes from allowing the rendering to happen as quickly as possible and having fixed time steps for your physics, which again makes sense, but you have to consider what you're losing when you go with that approach. So with that in mind, I decided that as a beginner still learning, it's probably best to approach it a little more simply and try to keep my updates and my rendering closer together. Okay. So how do you do that? Well, that comes down to capping your frame rate. And you do a search for that. It's easy to find a lot of tutorials on it. And basically what you do is you take a time marker at the beginning of your loop, and then you take another time marker at the end of your loop. You see how long it took you, and then you wait until you hit your target frame rate. So your target frame rate may be 16, 17 milliseconds for one iteration of your game loop, but it only took 2 milliseconds to complete all the work. Well, you have to wait around for the other, what am I at, 14. You have to wait for that. And there's a couple of different ways you can do that. You'll find that examples use a delay function, or they just kind of have a loop going until you reach your time. So it just kind of waits out the time. So I'll show you the second approach because using a delay function is tricky. I haven't figured out how to do it yet, and I'll explain in a moment. So let's go to the beginning of the game loop actually. So here I get the start time. Zoom in a little bit. Getting the start time is just calling SDL get ticks. Okay, so we get the ticks, and then we go through all of our work, getting the state of the keyboard, handling input events, and going through updates, rendering, even right here, rendering. And then I get the time again just before I'm about to render present, show the new scene. And if the end minus the start, so if the time passed isn't quite at the target frame rate yet, then I keep getting the end time to do a loop until I reach that target frame rate. And only then do we continue on with presenting the new scene right there. So that's one way to do it. The other way to do it is to use SDL delay and then delay for the amount of time that's still remaining. So whatever it ends up being. And that's in milliseconds, by the way. So we delay like 14 or whatever the number is, right? The problem with the delay is that you're relying on the scheduler for the operating system to wake up again and keep checking, okay, when should we come back to this program? And you need to be able to set the granularity for that, meaning you need to be able to tell the scheduler when to come back and check. Because if the scheduler only checks every 10, 15 milliseconds, and really you should only be delaying for 5, you'll actually end up delaying for the 10 or 15, whatever it is that the scheduler needs. And so your frames will be going longer than what you intended. So I'll link to other explanations of this down below. I just wanted to touch on it quickly, and you can get more into that if you don't quite understand it. And those links will help you understand it better. So this is the way I'm going. This is a simple way right now. Which frame rate to choose? Well, I'm not using VSync in my code. I want to keep it simple. So for now, so as I'm learning, so I'm setting my target frame time to match that of my monitor, which is 60 FPS. So my target frame time is about 16 milliseconds per iteration. And that seems to be working out okay now. I'm getting the smooth movement I want. I'm getting the fine control over player speed that I want. And later on, as I progress, I know that I'm going to discover a way to be able to handle different frame times. If I understand right, let me see, I think it's Jonathan Blow in one of his interviews discussing his programming of the game Braid. I think he does some work at the beginning of the game before things really get going to test the monitor to see what the refresh rates are. I believe that's how he did it, but I'll talk about that later on. Also later on, I'll share this little thing I've got going on. I had it on the screen a moment ago. This little bouncy back and forth. This was me playing with different ways of handling movement. If you see the red square at the top left there, if it's red, that means I'm not using the delay that I just showed you a second ago, this loop. But when you press C, you turn on that delay and you can see how things change a little bit. Okay. Anyway, I'll share that as well, and then you can play around with it and see, and that kind of helps you wrap your head around how different things work. Anyway, thanks for watching. Hopefully that helps you a little bit. If anything's unclear or you have questions, please post a comment. All the links to all the things that I mentioned will be in the description. I definitely recommend you check them out. Hopefully that'll save you some time. Okay. Anyway, thanks for watching and good luck.